What up, y'all? Here we go. Benchmark fractions. Benchmark fractions. That is what today is all about. Now, we have talked in the past, just recently, around that concept of benchmark being a really fancy word with fractions around estimation. We specifically focused on that idea around that benchmark of 1/2 so far, right? We kind of talked about like looking at certain fractions. Do we know, are they less than 1/2? Are they greater than 1/2? Are they exactly equal to 1/2? Um, we're gonna add to that moment, thinking again about multiple benchmarks to think about that judgment of values of a whole. That came out so crazy. So this will make more sense, but that's really what we're going to be doing today. Is we're in this video, we're going to be thinking about what are some different benchmarks besides 1/2 that we can use as judgment around how to estimate fractions when we add and subtract them. So I'm gonna first do this. Sorry, I'm eating a snack because I'm like really hungry, but I also want to get this going. So here's the number one, right? So one thing to think about, number one. Now, we did talk about that benchmark 1/2. And that's a good place to be thinking about like how close am I? Am I close to 1/2? Am I closer to less than 1/2 or larger than 1/2? But then we also want to be more specific. So we want to start like thinking about where benchmarks are at that we can round to. So one of the main ones is what we call the anchors of our number line. They're the ends of our number lines. Is we have 0. Like 0 is a benchmark, and that could be like something like 1 out of 1,767. Well, that's pretty darn close to 0, right? It's definitely not close to 1/2. It's definitely not close to a whole. So in some cases, 0 might actually be a benchmark, which in a sense isn't really a fraction, right? It's more of that value to help us with estimation. So that's one thing. And then the other anchor that we sit on is the extreme other side of a number line, and that would be 1, right? Which could be, again, something like if I had 999 out of 1,000. Well, I only need one more piece to make a whole, so I'm pretty close to 1. And then we also then have, get rid of that. We also have then this benchmark that we see here of 1/2 that we've talked about. But then we also want to talk about like other places that fractions can get split up if you're ready to take this on. I think this is a deeper level of understanding, which I'm into, right? So if we take 1/2 of our halves, well then that creates fourths, right? This would be 1/4. This would be 2/4 or 1/2. Those are equivalent. 3/4, 4/4. All right, 4/4. Sorry, I'm like putting that in parentheses. So then we also have this idea of fourths. So like 1/4 here, or even 3/4 here. These are also places we can start to play around with our benchmark to be more accurate. And then there's actually one more to lace into this. And trust me, I'm going to go through like 3 different ways to look at this number. And don't worry, if you're already like, man, this video just started, you're eating a snack, you're screaming at me, and now you're just throwing a bunch of fractions up there. Don't worry, it will make sense. Trust me, this will make sense. Another place in which we want to do like some common breakdown of benchmarks is those thirds. And so even on the same number line, again, if I like went about there, right? Again, this would be 1/3. This would be 2/3. This would be 3/3. And then that's another place that you can start thinking about benchmarks. Now, I'm going to play with these on the next screen to kind of look at visually what those look like in terms of pieces, which will help us with the addition and subtraction through estimation. So we have these benchmarks. Oh, this is going to be wild. I love this. Gosh, I love this stuff. But let's talk about that. So like, for example, right, if I'm going to try to stick with the same color system, if I had a square or a rectangle, right, and it actually wasn't cut into anything and it literally wasn't shaded, well, that would be 1. I mean 0, sorry. But if I had that same thing and I shaded it, well, that would be 1 whole, right? So there's those benchmarks. I don't remember the colors now. Oh yeah, orange. Okay. So then with 1/2, right? We did the same thing. We took the number 1 and modeled it as a rectangle. Right? That would be 1/2. I remember I did yellow for the third. So same thing. I took 1 and we cut it into 3 pieces, right? This could be 1/3. Um, there's also then, I guess this might help. It could also be 2/3, right? Could also be 2/3. And then some other benchmark. Oh yeah, green. The other benchmark was the 4th. So again, I could take that same one, cut it into 4 pieces, and if I had 1 piece, that would be 1/4. I feel like this is crazy. I don't have to do 2/4 because that would be the same thing as 1/2, right? Look, well, that's half of it, so that's this one, so no worries. But I could do 3/4. And again, I'm not going to do 4/4 because that's 1. But these are kind of those benchmarks that we're seeing and what they are. And then like, what does this mean when we're like estimating and thinking about values of that? Okay, so there's this picture, and then on the next one, I'm gonna do a little number line. So remember when I talked about like slowing things down and drawing lots of pictures and making sense? Like, really do think that's the goal. So I think even if you're taking notes in your journal, and you're like, whoa, hold on, like just pause this video real quick and draw this in your journal, right? There's no problems with doing that. So hopefully you did that and you just unpaused me and this is now in your journal. So let's then again talk about like, what does this really mean? Like, what does this mean when it comes back to these are my benchmarks? These are the places I can round to, and how does that help me? So the example would be something along these lines. It's like, again, we want to estimate. So that's why this first comes. So that's why we benchmark. It is estimation. So someone says, "Oh, I don't know." I love how it's always like someone just comes along and starts talking. Hey, I just want to know if I have 7/8 and I'm going to subtract 5/12. Well, at this point, that's a more complex of a problem we haven't really dug into, but we can estimate the difference of this, right? We can look at what would this mean. So we have these pictures to keep in mind when it comes to adding and subtracting. But also, if we look at this, let's just look at this whole grand scheme of thing as one giant number line. And so that can get complicated because we're putting all these different things on one number line, right? So here's, like 0 to 1. And then right in the middle would be 1/2, right? Okay. And then we have these fourths. So this would be like 1/4. This would be 3/4. Remember, this is 2/4. That's the same thing as 1/2. They're equivalent. And then we have these thirds. And I would say that goes what? Boom. Like that. And again, if you don't see it, I'm just gonna like, right? That's the third right there. 1/3. And then there's like a second piece right here, which is 2/3. And then this, of course, would be the 3/3, which that would be that third piece there, if you see it. So that's where the thirds come from. Of course, now I have to erase all that because it'll get confusing. Okay, so that's where we can put all these benchmarks on one fraction. And that's a big skill. That is actually like learning how to take one number line, but put all these different measurements on it. That it's a skill you'll learn and do, but that's something right away to be thinking about. So that's all of them. Now, again, we're estimating. So we're actually thinking about this concept here. And I'm gonna actually do it in a different color so it sticks out. I'm gonna go with 7/8. I'm gonna kind of call that purple. So we're looking at 7/8 here. So let's break apart what that would actually mean is like which one of these green or orange or yellow or even black numbers written in these colors, like which one of those benchmarks, because these are my benchmarks, which one of them would 7/8 be close to? Well, one way to actually make sense of that is that I could still then cut this number line into eighths, right? So this would be half. And we talked about half. Half of 8 would be 4. So that'd be 4/8. And this would actually be 6/8. And you'll see why, because I would take half and half, right? And same thing here. This would be, this one right here would be 2/8. And then again, we would take half of that, half of that. And you can see it. Like this would be 1/8, 2/8, 3/8, 4/8, 5/8. Notice that's the purple, 6/8, 7/8. And then this would be 8/8. Well, if we looked at that, if we thought about 7/8, which is right here, then we can already determine like which benchmark is this closest to. And so again, we have some work to do because if we think about what we talked about in terms of like hops, it's true, like one hop gets me here, one hop gets me here. So actually 7/8, in a sense, it's pretty close to 3/4 as a benchmark. It's also pretty close to 1 whole as a benchmark. But I also think about like how in this case, I kind of want to round up because I'll be working with a whole number. That's a good thing to keep in mind, right? So this is one of those things right away where I'm like, gosh, I kind of have a choice here. I could do one or the other. I think it's always wise to then kind of round up and say to yourself, okay, well, 1/8 or 7/8 is closer to 1 whole. So what I'm going to do is I'm going to round this to 1 whole, right? And then next, I'm thinking about 5/12. Well, now look at this number line down here. It's crazy. It's got things all over it. In fact, what color let's do pink. Let's say 5/12 is pink. Now, I know what you're thinking right away. Gosh, I got to cut all this into 12 pieces. I'm actually going to do a little shortcut here, and I'm going to think about half. Because one thing I know about half of 12ths, that would be 6/12. So that means that 5/12, right, generally is probably like around here somewhere, right? It's smaller than 1/2, but it's really close to it. So actually, what I get to do here, oh, this is messy. I have so many things on this. I don't like this. I like the model, but I just realized I don't have space to write what I'm doing. So hold on. I'm going to clean this up real quick. So I'm going to get rid of this up here, and I'm going to shift these numbers up here for us. So let's do that shift real quick. I'm going to come up here. So I'm rewriting this stuff up here. So 7/8 minus 5/12. Now, what I did is we just rounded 7/8 to 1 whole. I hope that made sense. And then actually we just rounded 5/12 to the benchmark of 1/2. That's the part that's difficult is remember the benchmarks you're using are these. It's like in this case for the video, it's the idea of the purple benchmarks, the green benchmarks, the orange benchmark, and the yellow benchmark, right? So I'm going to round this to 1/2. And then here's my work here. So if I just estimate, man, I got to erase a lot of this. I'm sorry. This is a good example. This is not a good spacing to make sense of it. So now I'm going to take this, and if I have 1/2, or if I take 1 and I take 1/2 away from it, I'm going to just end up with about 1/2. The next example, I'll do better, right? So that's what this is. 7/8 minus 5/12 is about 1/2. It's about 1/2. And again, I did that through estimation. Oh, gosh, I'm sorry. That was crazy. So let's do another one so maybe it's a little bit cleaner. So same idea. I'm going to take, and we are going to estimate some fractions, but we're also going to do it using benchmarks, which are those, again, these are my benchmarks, and you can see them here. Not there. Here, 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 and here. So what is that? 1, 2, 3, 4, 5, 6, 7. So about 7 options we can round to, okay? And again, I visualized it here. And that will help us with the subtraction. But okay, so let's come to this one and let's try this again. Let's try a different problem. What if we had to do something like, estimate 11/12 plus, I don't know, 1/6. Okay. All right. So let's play around with that. First, visualize. So let's visualize the number line with the benchmarks. So there's always the 0 benchmark and the 1 benchmark. There is the half benchmark. There is the fourths benchmark. And remember, that's also here because that's 2/4, but it's 1/4, 3/4. And then there's the third benchmarks, which are always a little bit harder because they don't really have a system. Like sometimes it's kind of hard to see them where they would be. So this is 1/3, 2/3. Okay, so these are my benchmarks. The goal is then to say, all right, 11/12, like which benchmark is this close to? And again, there's some reasoning in here. Like I could cut this whole thing into 12 pieces. It's 11/12, so right in the middle would be 6/12, right? Which then let's see, that right about here, actually not even right about here, right here for sure would be what? 8/12, right? And this would be 12/12, and this would be 4/12. Again, right? See, I'm using like equivalencies. And so actually like right there, I don't have to go any deeper. Because like this one would be like 9/12 right here. But I'm not gonna go any deeper because at 11/12, I know that's gonna be like right-ish here. Again, kind of using a bit of estimation. Um, so with that being said, looking at this 11/12, that's going to be closest to the benchmark of 1. So I'm going to take 11/12 and I'm going to round it to 1. Now we want to look at 1/6. Okay, so again, think about what we know about halves. And again, look, our number lines are this messy. So I hope it kind of makes sense of where I'm putting numbers and why I'm putting in there. So let's see, for the sake of this one, I'm going to go here. And make it purple. So one thing I know about sixes is that half of 6 is 3. So right here at 1/2 of my number line, this would be 3/6. And then that really means what? 1/6, 2/6, 3/6, 4/6, 5/6, roughly. And then 6/6 is 1. So if I'm 1/6, I'm right here. So again, now I have this debate of like what looks closest, right? Is it closest to round this to 0, or could I round this to that 1/4? And if I look at my picture, honestly, like look at the arrows, the spacing, and this is why it's good to do this work. Let's see, what's a color we haven't really used since all this is crazy, right? The spacing in between here, this space, it looks just a little bit smaller than this spacing here. So it actually looks like the closest thing is 1/4. So I can round this 1/6 to 1/4. And so now if we're doing that kind of math, oh, I guess, sorry, I used fourth as a green. I should stick with that color scheme. If we think about that in math, I have 1 whole plus 1/4. So that is literally just 1 and 1/4. And we could even go back and look at that with this here, where again, these are the pieces I'm putting together. And if I put those together, that's literally what I would get. I would get 1 whole rectangle plus another rectangle cut into 4 pieces with 1 piece shaded. Therefore, when put together, that is 1 and 1/4. Okay. So that's also why I like the bar model, because it gives me an idea to help add and subtract. Okay, so I hope this is starting to make a little sense of what we're doing here. And like, again, like look at the wacky number lines. Like, look, I'm putting so many numbers on them, but they're also all equivalent. I'm also using like some of those estimation techniques of thinking about what is half, therefore, where would my fraction be about? Therefore, which benchmark would I round it to? So let's do one more. I know this video is kind of going long, so I'm going to try to do this one quickly. And what I'm going to do first is I'm actually going to build that number line first, because I think maybe that was building it on the bottom got confusing. So here's the benchmarks of 0 and 1. Then we have split right in the middle or in half. Then we also have the force. So 1 force. Now remember, this is 2 force and 3 force, right? This is 0 force if you need that, that's fine. And this is 4 force if you need that, because that's a whole, that's fine too. And then we also have thirds. And thirds, again, are when you cut the number 1 into 3 pieces, and that can be difficult. So this is 1/3, 2/3, and 3/3. Finding the middle in thirds is difficult because that means you're finding the middle of 3. So just keep that in mind. That's why you see these are a little off-centered from the whole. And I would also like even note here that in my own model, if I'm drawing thirds correctly, actually this space and this space should be pretty equal, and it doesn't really look equal. But then again, I also notice, right? And this is, I don't know, I like this because this is where you get to edit a lot. You get to revise your thinking. I actually noticed too, I think that this half needs to be moved over a little bit. So that's what I'm gonna do. I'm just gonna move it more here. I think that's actually more about where half is. And again, we're doing this with our own hands, so it's okay when sometimes like you're making some mistakes in that process. So don't worry about it. That's again, you can make sense of it and then you can edit, right? You can revise your thinking. Okay, so there it is. So those are all of our benchmark fractions on a number line right away. So if we were to go into some work, and let's say this time we're doing, let's say we are going to estimate 14 sixteenths and we're going to subtract. So let's do a difference. We're going to subtract 5/8. So now again, remember, we're going to round 14 sixteenths to one of these many benchmarks up here, whether it's the 0 or the 1 written in the black, whether it's the force written in the blue, the half written in the orange, or the yellow written in the the thirds written in the yellow. So let's play around with what that means with 16th. And maybe I'm gonna, not even maybe, I'm gonna again change the color so we can see it on the number line. So 14 sixteenths, we're gonna look into red. Now, if we put sixteenths on a number line, well, half of 16 is 8. So this would be 8 sixteenths right here. All right. This would be 16 sixteenths. And let's see, in the middle of those two, which would actually be right here as well, this would be 12 sixteenths. So we now, even thinking about counting, right? Even if it's not the exact location, let's say I'm gonna put it right here. Here's 14 sixteenths. Well, now we can kind of make sense again about like, where is 14 sixteenths? It would be again, and I'm gonna just like look, I'm thinking numbers 10, 11, 12, 13, 14, 15, 16, right? If we're here, it's 1, 2 jumps to 16, which would be 1 whole, or it's 1, 2 jumps to here, which would be 3/4. Now, again, in this scenario, what I say is always it's pretty good if it's the same either way, like it doesn't matter. It's just as close to 3/4 as it is to 1 whole. I would prefer to round this to 1 whole because it's easier to work with 1 whole and fractions because you have 1 and then what are you taking away from that? Okay. And then we got to subtract 5/8. So let's look at where 5/8 would be. Again, if we were looking in eighths, that would be 4/8 is in the middle, which means actually 5/8 is, I don't know, maybe about here. So automatically, I like that. This rounds right to 1/2. So I'm going to round this one to half. And then we're going to do that math. 1/2 or 1 minus a half. Well, again, and I'm going to go the long route on all of these. So a lot of times you're going to have to deal with me watching and drawing all these pictures of like why we're really doing this. I really want you to do it. I really do. It's going to be so helpful. Anyway, but let's just say we have 1. Okay. And we're going to work in half. So I'm going to cut it in half. But it's 1, so I'm going to color in the whole thing, right? So that's 1 whole. I hope that makes sense. This is my 1. But then I'm going to end up subtracting one of those halves. I'm going to get rid of the half, right? We subtract it, which leaves us with, sorry, I'm just trying to find a good color for this, leaves us with what's left is the 1/2. So 1 whole minus 1/2 equals 1/2. And that part can get a little tricky, so don't worry. So that's the estimation of that. Okay, super long video, but I think meaningful. So I want you to try this out and play with it. Like, again, think of all the number lines you're going to have to create to play around with and draw things on. And then remember those benchmark fractions. So I'm going to go all the way back to this. Like, visualize what they are, but also remember how they like all fit on one number line together as well. So that's what work we're doing. That's estimation. That's benchmark fractions. That's a lot, but you're awesome. Ask questions, practice, do the work. All is well. Keep up the good work. You're great. I think I already said that. We'll see you at the next time. Keep it real. Peace out. Word, all those other cool things.